Now in this next video, we're going to go even further away from the linear searching approach with merge sort. Merge sort takes a divide and conquer approach to ordering the list. It does this by literally dividing up the list. As you can see from this graphic, the function recursively splits the list in half, or as equally as possible, until it comes up with a base case, where we have a list of only one item. This list is intrinsically ordered because there's only one item. Once this list is split, we can perform the namesake method of this function, merge it again. It takes each of these smaller lists and, as you guessed, merges them. It does this by repeatedly taking the smallest item from either list and adding them to the final list. Once it's done, the result is returned. So let's see how we do this in practice. We're starting with our function from the GitHub repository. Because this is a recursive function, we're going to need a base case. Now this is if the length of the list we're being sent is larger than 1. So if it's smaller than 1, we're not going to do anything. If it's larger than 1, we are going to do something. The first thing we want to do is find our midpoint. So this is the point where we're going to split our list that we currently have up in half. So mid equals len of numbers, and we're going to use a floored divide by 2 because that gives us a square, a round number. It doesn't give us any decimals. Once we have this midpoint, we can divide our list up into a left list and a right list. We're going to, of course, split our numbers list into each of these, and we can just use the function built into Python. So that should be there. Okay, we're going to do the same thing again for our right list. So we've got our two lists. Now we can recursively call merge sort on each of these lists because of, as you saw in the graphic before, we do the layers down. Merge sort left half. Okay, so we've got our two ordered sublists, and now we need to merge them back together. Before we do this, I'm going to set up 3 functions, x, y, and z, and they're all going to equal 0, and you'll see what I'm using those for in a sec. Okay, while x, which is the number we're going to use to represent the current position in the left array that we're looking at, less than the length of left half, which means there's still numbers in the left half that we haven't looked at, and y, which we're going to do the same thing for the right half, we're going to do some sorting. So the first thing we're going to do is check which number, either out of the left list or the right list, is larger, and then we're going to put either of those numbers into our overall sorted list. To do that, we'll go left list x is greater than right list y, because that's our position in y. Now, if the left is greater than the right, we want to put the right into our current position in the overall array. So we're going to put it into numbers because we're just going to reuse that array. It means we don't have to return anything. Numbers z, which is our overall position in the whole numbers array, we're going to set it to our current number in our right list, and we're going to increment our current position in the right list because we're now one further into it by 1. Else, we're going to do the same thing with the left list. So we're doing the same thing with the left list. And finally, we want to increment our overall position in the final returning list. So we'll just do that there. The next thing we need to handle is, of course, if the lists are uneven in length. Do 2 functions to handle this. So while x is, x is less than the length of the left list, we'll add any of those remaining numbers to our overall list and increment both the position in our left list and the position in our numbers list. And we'll just copy and paste this again, changing it to handle if the right-hand list is longer. So our function seems ready to go. So let's run this and see what we get. Okay, I missed one thing. Up here should be a 1 instead of a 0. And I also went left list instead of left half. And there as well, because I'm having a really off day. Okay, so there is our sorted list from this function. So let's talk about the efficiency of this now. Each pass of splitting and combining the list again is log n, where n is the length of the list. And we run this n times. So the overall efficiency of this method is n log n. In the next video, we'll be covering our final sorting algorithm, the quicksort.